Namaste everyone. Welcome you all to Sadvidya Academy Science Classes by Ganesh Habal. Today's topic we are going to discuss is Class 10 Physics, Chapter number 12, Electricity, Part 3, that is Ohm's Law. Before moving ahead with the statement of Ohm's Law, we have to know what is it and which is the experiment which is used to find out that particular law. So what is Ohm's Law? It is a law which relates the potential difference V and current I. In the previous video, part 2 of electricity, I have discussed about what is potential difference. You can go through this to know about the potential difference. So this Ohm's law is a law which relates this potential difference V and the current I. So there is an experiment which is conducted in order to prove this particular law. So what is that experiment? The circuit diagram to prove this particular Ohm's law is given as shown in the diagram. So it is a circuit diagram. So you can see that in the circuit diagram. So it has one R, that is nothing but the resistance. We call it as the resistance. It is nothing but a nichrome wire. Nichrome wire which we use. So what is a nichrome wire? Nichrome, it is nothing but an alloy. So this what is R? R is nothing but a nichrome wire is used here. Nichrome wire is used as R. So what is nichrome? It is nothing but it is an alloy of nickel, chromium, manganese and iron. It is an alloy. It is a mixture of nickel, chromium, manganese and iron. So that is called, as you have studied in your lower classes, what is an alloy. So that wire is an alloy of nickel, chromium, manganese and iron. That is called as nichrome, the short form. Nichrome, nickel, chromium, manganese and iron. Okay, so that is placed here in place of R, and there is a voltmeter which find out, or it gives the reading of the difference in the potential between the two terminals of that particular nichrome wire, and there is an ammeter which is connected to measure the current flowing through the circuit, and there are 4 different cells which are connected, and why these are 4 cells we shall discuss it now. So what is done? What is the experiment? How to proceed with the experiment is, so in order to proceed with the experiment, what we have to do is we have to connect this particular circuit as shown in the diagram. Then we have to draw this particular table. So what we have to do is we have 4 different trials in this experiment. So for the first trial we connect only one battery like this. For the first trial what we do is we connect the circuit like this. So current flows through this and it will move back to this particular point. So there is an voltmeter to measure the potential difference, and there is an ammeter to measure the current flowing through the circuit. So what we do is when one cell is connected, so we find out when the key is switched on. This is nothing but the key. It is nothing but a switch. So when it is switched on, what happens? If it is a digital meter, it will give some readings in the voltmeter as well as in the ammeter. If it is analog, it will give some deflections. By finding that deflection, we have to note down that values. Whatever the value you get in the ammeter, you write it here, and whatever the values you will get it in the voltmeter, you write it here. Record the values. For the number of cells connected is only 1 for the first trial. Now go ahead with the second trial. So second trial, how it is performed? Second trial is performed by connecting 2 cells like this. Now in the circuit, how many cells are there? 2 cells are there like this. So now what should happen by general knowledge? When one cell is connected, if V is the voltage, if two cells are connected, what should happen? Voltage also should increase, as well as the current also will increase. It will change. So record these readings as well. Record the readings, the present readings of voltage as well as the current here in this given tabular column. As well as for the third trial, now connect the three batteries like this. Now current flows through this like this. Three batteries are connected. Now what happens? Again the voltage as well as the current will increase. Record these values. Write down these values here. Again for the fourth trial, again you connect the fourth battery also. That means now all the four batteries are connected in the circuit. Now again the voltage and current, or current and voltage will increase. That is why record these values here. And after recording the values, what is your work is? You have to calculate the ratio of V by I. What is mean by ratio? You have to simply divide the potential, this particular column value, divided by this particular column value. So V by I values you have to record. That means you have to calculate all these values and write them here. And a very interesting observation you will get is that the values of V by I for all the values will be constant. So these values of V by I, that is the ratio of potential difference to the current in all the trials. Even if you have connected one battery for first trial, two batteries for second trial, three batteries for third trial, and four batteries for the fourth trial, you will get this particular value, that is V by I, same for all these values. For all the values of all the four trials, you will get V by I is the same. What is the observation we can draw out of that constant value? So in order to draw some conclusions, what you do is you plot a graph of V versus I like this. So it is a graph. By taking a graph sheet, take the sufficient scale in along y-axis as well as x-axis, and write along the y-axis potential difference, along the x-axis is current, and plot that graph. How to plot the graph? You already know how to plot the points in a graph. That is, V is taken along, this is V, voltage is taken along the y-axis, and current is taken along the x-axis. Plot all these values along x-axis and plot all these along the y-axis. You will get four different points like this. So always remember that all the 4 points will be in straight line, such that that straight line passes through the origin. That straight line passes through the origin as shown in the diagram. What is the conclusion you can draw out of this is, that means the graph of V versus I is a straight line passing through the origin. That indicates that the values of V and I are proportional to each other. V by I is equal to constant you will get. V by I values you will get constant. That itself is nothing but V and I are directly proportional. What is the meaning of directly proportional? As V increases, I also increases, or as V decreases, I also decreases by the same proportion. That is the meaning of directly proportional. So now it is a time to state Ohm's law. That statement we shall discuss in the coming slide. Now we shall look into the statement of Ohm's law. So what does the Ohm's law state? The statement of Ohm's law is, it states that the potential difference V across the two ends of a metallic wire is directly proportional to the current flowing through it, provided the temperature remains the same. Let us see the meaning of this. So the potential difference V across what? Across the two ends of a metallic wire. There the metallic wire we have used is the nichrome wire, right? So nichrome wire we have used. So there is a resistance like this. This is represented by X and Y. Across it we have connected a voltmeter. Am I right? So we have connected a voltmeter like this. So this potential difference, whatever the reading we get in this particular voltmeter, that is proportional to what? Proportional to the current flowing through it, that is current flowing through it I, provided the temperature remains the same. That means, what is the meaning of directly proportional? Directly proportional means as V increases, let us assume that I have increased the value of V. How to increase the value of V? In place of taking one battery, connect to two batteries. At that time what happens? The potential difference increases. In that time, according to this law, what does it say? When I increase the potential difference, I also increases. V increase ಆದರೆ I ಕೂಡ increase ಆಗುತ್ತೆ. That is the meaning of directly proportional. As V increases, I also increases. Or when V decreases, I also decreases. That is the meaning of directly proportional. Now V is directly proportional to I, provided, that statement is very important. The statement is incomplete if you write only till here, is directly proportional to current through it. Then the continuity is provided the temperature remains the same. So this Ohm's law holds good only at constant temperature. Constant temperature. The temperature should be maintained constant while performing the experiment at constant temperature. That means Ohm's law holds good only at constant temperature. So V is directly proportional to I. Or in order to write a proportionality constant, that means in order to convert this proportionality equation into an equation, how to convert? So there we have to incorporate a constant called as proportionality constant, so that I can change this proportionality sign into equation sign, that is V is equal to some proportionality constant R into I. That is V is, or I can write V is equal to I into R. This is the formula of, or the relation between the V and I. V and I. V is the potential difference and I is the current flowing through the circuit. And where R is called, where this R is actually a proportionality constant, but its name is, it is called as the resistance. It is called as the resistance of the circuit. What is the meaning of resistance? It is called as resistance. So what is the meaning of resistance then? The meaning of resistance, it is actually a proportionality constant. That means it remains a constant in a circuit. So what is resistance? Resistance is nothing but the definition of resistance. It is nothing but it is the opposition offered to the flow of current in a circuit. So that resistance, the general meaning of the dictionary meaning of the word resistance itself is, it is the opposition. So opposition offered to the flow of current in a circuit, that is called as the resistance. It is indicated by the letter capital R. It is indicated by the letter capital R. So now what is mean by resistance? So it is the property of a conductor to resist the flow of charges. So what is the meaning of resisting? So if someone is moving, we are opposing that particular person from moving. If that is the case, we say that we are resisting that particular person from moving. Like that, inside any conductor, when charges are moving inside the conductor, what happens? The conductor resists the flow of charges. At that time, what happens? The current, of course, it will decrease due to the presence of resistance. So resistance is nothing but it is a property of a conductor to resist the flow of charges through it. So how to measure that resistance? How to measure that resistance? There should be some quantity to measure, or there should be some unit to specify how much resistance that particular conductor will give to the flow of charges. So the SI unit of resistance is ohms. So look at this particular symbol. So this is the symbol called as ohms. So ohm, this symbol is called as ohm. It is represented by like this. It is written as like this, ohm. So SI, that is called as the SI unit of resistance. SI means system international, or international system of unit of resistance is ohms. So then how to define 1 ohm? Before that, in order to define some smaller units of ohms, we here also refer it by microohms, milliohms, etc. Here, say for example, always the resistance will not be 1 ohm. Sometimes smaller values of ohms, how to represent? By using different prefixes which we have studied already, milli, micro, centi, etc., mega, like that, or kilo, higher units in order to measure, kilo, mega, like that, kilo ohms, mega ohms, like that we represent. These are also some of the larger units of measuring the resistance. Then now how to define 1 ohm? So the resistance has to become 1 ohm. When it will become 1 ohm? That is a question. So we know that this is from which formula? This is from which formula? This is from V is equal to IR is from Ohm's law, right? So V is equal to IR. This is obtained from Ohm's law. So V is equal to IR. This is a very important relation, or which is very important for problem solving as well. V is equal to IR. It is a very important equation. Or if you rearrange this particular equation, so R, retain R here itself and move that I towards the left hand side. So that what happens? R is equal to that I becomes towards the denominator. So R is equal to V by I. Now how to define the resistance? R is nothing but the resistance. This R is nothing but the resistance. How to define that resistance as 1 ohm? So that we have to study. Then when this particular R becomes 1 ohm, so SI unit of R we have already discussed, that is ohm. So when it will become 1 ohm, so this particular left hand side becomes 1 only when the V is 1, that is 1 volt, and I is, that is current, is also 1 volt. Then only 1 by 1 itself is equal to 1. Then only we say that, sorry, this is not 1 volt, this is 1 amps. Okay, then only we say that the resistance is 1 ohm. So how to define 1 ohm? Can you try to define? So 1 ohm is defined as, it is defined as 1 ohm. I am defining 1 ohm now. It is defined as it is the resistance offered by the circuit when 1 ampere of current is flowing in a potential difference of one volt. That means 1 volt is defined as it is a resistance offered by the circuit when 1 ampere of current is flowing in a potential difference of 1 volt. So when the potential difference must be 1 volt as well as the current flowing through the circuit also should be 1 ampere, then the resistance offered is said to be 1 ohm. That is the definition of 1 ohm. That is the resistance is said to be 1 ohm when 1 ampere of current is flowing through a circuit when it is kept in a potential difference of 1 volt. So this potential difference also sometimes called as voltage. So the potential difference is also called as voltage. Remember, so voltage and potential difference are one and the same. So that is about the voltage and the relation between voltage and current, and that is nothing but the Ohm's law. So next we shall solve some problems related to Ohm's law and the previous formulas which we have discussed. The first problem which we are going to discuss is calculate the number of electrons required to constitute a charge of 4.8 nanocoulomb. This symbol it is small letter n capital C, that is nanocoulomb. What is the meaning of nanocoulomb? We shall discuss. So in order to calculate this, first we have to write the given values. What are the given values? So they have given the charge Q is equal to how many? That is 4.8 nanocoulomb. How to write nanocoulomb? That is 4.8 into 10 to the power of minus 9 coulombs. That is called as 1 nanocoulomb. So they are asking, in order to form a charge of 4.8 into 10 to the power of minus 9 coulomb, how many electrons are required? How many electrons are required? Electrons are required, they are asking. So how to find out that? So we know that 1 electron, what is the charge of 1 electron? It is 1.6. Actually it is minus, we neglect that minus for the timing. 1.6 into 10 to the power of minus 19 coulombs. 1 electron has a charge of how much? 1.6 into 10 to the power of minus 19 coulomb. Then asked charge is how much? 4.8 into 10 to the power of minus 9 coulombs. Here it is 19, here it is 9 is asked. For forming that much of charge, how many such electrons are required? How to find? It is just a cross multiplication. That is 4.8 into 10 to the power of minus 9 divided by 1.6 into 10 to the power of minus 19. That we need to calculate. The answer will be 4.8 divided by 1.6 is 3. 3 into, that is 1.6 ones are 1.63 are. So 3 into 10 to the power of minus 9 minus 19, it is in the denominator. When it goes to the numerator, it becomes plus 19. So what we can write is 3 into 10 to the power of minus 9 plus 19, that is 10. So 3 into 10 to the power of 10 electrons. That much number of electrons are required to form a charge of 4.8 nanocoulomb. So the next problem is the second problem is 2 coulombs of charge is flowing through a conductor for 0.5 seconds. Find the current through the conductor. That is, what is the given value? Given value. How many coulombs of charge? Charge is given. Q is equal to 2 coulombs of charge. Is flowing through a conductor for how much seconds? For 0.5 seconds. That is, time is given. Time t is equal to 0.5 seconds. What is asked? Find the current through the circuit. That is, current I is equal to how much? How to find the current? We have the formula I is equal to Q by T. That is the rate of flow of charges. That is ratio of charges to the time taken. That is equal to the current. That is, Q is given, that is 2, divided by time is given 0.5, which is equal to 0.5 ones are 0.5 fours, that is 0.5 times 4 times 0.5 equal to 2. That is, I is equal to 4. What is the unit? Unit writing of the unit is very important. So it is the formula for current. That is why it is 4 amps. That is the answer. The third question we are going to discuss is, how much work is done on each coulomb of charge passing through a 12-volt battery? The asked question is, say for example, how given values. We shall write down the given values. Given values we have to write first. So given, what is given? So how much work is done on each coulomb of charge? That means the charge Q is equal to 1 coulomb. Each coulomb, work done on each coulomb, that is asked. That is why the Q is equal to 1 coulomb passing through a 12-volt battery. So that coulomb of charges, 1 coulomb of charges are flowing through which battery? A battery of potential difference 12 volt. So the work done is equal to how much on a single coulomb of charge is asked. So what is the formula? We have the formula for, we have which one? So the potential difference, formula for potential difference we have. So formula for potential difference is the work done per unit charge, work done per W by Q. The formula is W by Q for V. So they are asking W. So what we require? This implies W is equal to, work is asked, work equal to V into Q, which is equal to, V is 12 volt into Q is 1 coulomb, that is equal to 12. But what is the unit? They are asking the work done. So work done should be, what is the unit of work done? It is joules. Remember, 12 joules of work is done in moving a single charge in a battery when it is connected to a battery of 12 volt. So that is the third problem which we have discussed. Problem number 4 is, how much current will an electrical bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm is the question. So given, first we have to write the given values. This is the question from Ohm's law. So given values are, how much current will an electrical bulb draw? That means current we need to find out from a 220 volt source. That is, potential difference is given, that is 220 volt. If the resistance of the bulb filament is 1100 ohm, that is R is given, that is 1100 ohms, that we need to find out how much current will an electrical bulb draw. That is, current I is equal to how much? So we have from Ohm's law, V is equal to IR, or I is equal to V by R. So which is equal to, V is 220 divided by 1100, that is 1100. So 1010 cancels here. So 22 divided by 110. So 22 ones are 22 fives are is, which is equal to 1 by 5, which is equal to 0.2. 0.2 what it is towards the left hand side, it is current, so 0.2 amps is the answer. We shall sum up the concepts which we have discussed today. First we have discussed about experimental arrangement of Ohm's law. Next we have discussed about statement of Ohm's law. Next we have discussed about relation between potential and current and the definition and SI unit of resistance. That's it. So thank you.